Gotta love that jingle. Hey, welcome back to another episode of Starburst TV. Today's topic is data virtualization in the cloud era, and I'm happy to have today on the show Dr. Daniel Abadi and Andy Mott, two friends, the authors of the book. And so let's jump right into it. Welcome to the show.
Thank you, Julian.
Let me introduce your book a little bit, and then I want before we kind of get into the details, I want to talk about kind of the journey in writing the book and so forth, and then we'll actually get into the contents. Let's get some fun stuff in there first. Andy, you looking good? Why is it so dark where you're sitting?
Because I live in England and it's always dark.
Fantastic, fantastic. Yeah, let's. It's the book is not dark though. The book is quite enlightening. I kind of went through and I think there's two chapters that we've released early, and I understand if we're lucky, there's another chapter coming right before the holidays, and so looking forward to that. In these first two chapters, we get into initially the introduction about the challenges of virtualization, which resonated with me. We talk about this with our customers all the time, right? And so I think you talk with some customers that have tried it in the past. It's not a new topic, right? They may have tried this in the past and it didn't work, or they didn't get what they really wanted. And you have customers trying it right now. And maybe different expectations of the way that it should work, or really not sure exactly how they should be using it or how they should be configuring it. And I think that first chapter really touched on some great ideas. And then you get into the second chapter where you're jumping into, bam, which I think is the money chapter so far. If you've got anything better than that one coming forward, it's going to be a really good book, because I really loved the second chapter in your early release, talking about the push and versus the pull. I don't want to steal your thunder as we get into it, but I got to tell you guys, I have really enjoyed reading it so far. I can't wait to see some more. Why this topic? Tell me a little bit about why you guys picked this topic for this book.
Well, I guess I'll take that one. Data virtualization and has been around for a long time, decades really. We were talking about it in academia and also in industry as well. And it really sort of never worked in the past. It really there were issues with it. It really, it's much more complicated than you think. It seems like, of course it should work. Just have your data in different places and have some layer above it and speak to all the locations, and it should just work. And the idea is very simple, but the practice is very hard. And there's a lot of details that go into it that just make things tend to be either complex to use or to install or to get running with good performance that really have held it back for a long time. And what we've seen in the last few years is that now all of a sudden it's starting to work, like just surprisingly, kind of out of nowhere. Like it's been known as like this this great dream for a long time. It never really worked until recently. So it felt like now was the right time to write the book. First explain why it didn't used to work, or what the issues were, the challenges were, but then what's changed recently, and why why it is working now, and how to get it to work better now. These are important topics, and I think that now's the right time to write the book.
Fantastic. Andy, anything to add to that?
Yeah, so I'd echo that. I in my role at Starburst, I spend quite a lot of time talking to partners and customers around this topic, and I find myself repeatedly repeating this this mantra, I guess, around that data virtualization is now a thing and it is viable, and it's it's a mindset shift. You have to say that quite carefully. I have to try and explain to people that actually exactly what Daniel said, this hasn't worked, and people have got that experience. But actually, there's a lot of things that have happened in the industry, outside of data virtualization, a lot of technology advances that, with the latest technologies around data virtualization, kind of come together and give us the ability to revisit data virtualization as a topic. Hopefully that I won't be repeating myself a lot, and we can just use the book in
Let's get into that first chapter. I think we open up with 5 challenges to data virtualization, and I think we very quickly come back and say, and here's what's changed, right? Here's why it works today where maybe it didn't work before. We don't have to go through each of the 5 challenges, but what are those challenges still valid today? Or are they old challenges? Let's first address that topic. Are they old challenges, or are they still current and now we can fix them? Or are they old challenges that have now just disappeared because technology's changed?
Yeah, I think that's still current, and I think it's if you do it wrong, if you build a system wrong, or if you use data virtualization tools wrong, you still hit those challenges. So I think it's very important even today for people to understand what the challenges are and why why they exist and how to avoid them. I think that's a very important chapter for people to read. So just give you an example of a flavor. I mean, just at a high level, most of the challenges come out of the fact that most of the time, the way data virtualization works is you have different systems talking to each other, right? So you have, maybe a data management system like Oracle or Postgres or MySQL, or you have other types of, NoSQL solutions, or any solution that stores data that may be relevant to a task sort of is a separate system relative to a data virtualization system, which is talking to it over some sort of communication mechanism. So whenever you have different systems talking to each other that are not one, they don't know each other, they're not built together, they're not designed to really from the beginning to work together, then you always have challenges that come into play, right? They speak different languages, potentially. You change what you update one system, and then you don't sort of immediately update the other system because the different systems, the different people writing those systems. So there's just sort of like in many cases, a communication mismatch across systems, which really can cause problems. So, for example, we talk about one big issue that comes up is query optimization. So one thing that every sort of any analyst task that you want to do with the system is you ask a question, and the system decides, okay, how should I answer this question? What are the processes in place to answer this question? You do this, and then do this, and then do this, whatever. There's different algorithms for answering this question, and you have to decide which one to do, which of these options to choose to answer the question. And the problem is that in order to choose which one to use, you have to understand the costs of the options, right? So if I do this, it'll cost this much as far as money, or as far as time, or as far as other key resources, memory, and so on that we need to be aware of. And if you're, it's very hard to predict in a different system what resources are they going to use. Are they going to use a lot of memory? Are they going to use a lot of CPU? Are they going to be slow for this algorithm and other algorithm? So it's just very hard when dealing with different systems to be able to predict how a different system is going to run a particular option that it's considering to answer a question. And that problem has existed for decades. It was 2 decades ago, 1 decade ago, 3 decades ago, and even now it still exists. And that's one of the things that comes up.
That's the pain point I hear all the time, right? People that have tried this in the past, that federation across a lot of systems, and they'll get burned because they're either unable to communicate with the system, or they're unable to optimize how they communicate and who does what, right? You're doing too much on your end, or I'm doing too much on my end, or you promise that you can deliver X and then something fails, right? Because of that communication, because of that lack of optimization, ultimately you're not able to get the performance, or, and this is the key, right? Or the cost that you're looking for, right? You end up spending way too much and waiting way too long. And then you look back and say, well, yeah, I should have just done it the old way, so to speak. And so, but that's not the case anymore, right? Today, if we say, okay, well, hold on a second, let's take a look at that communication. Let's take a look at that query performance. Let's take a look at how we kind of manage. There are new capabilities, new technologies, as you referred to in your book, that kind of allow us to then start to overcome that. Andy, can you talk a bit about what we're doing differently?
Well, so I think then you start getting into kind of the second chapter that we've kind of released, and you start getting into the push and pull based kind of architectures a little.
Where'd you get the push versus pull? Is that, and I love the way you framed it up.
This is Daniel's.
Daniel, that's fantastic. And I even like the little wedding analogy you use in there, right? Because it makes a lot of sense, but framing it up that way, and it's simple language. Sometimes we need simple language to understand some, because don't get me wrong, this is a technical book. I'm not trying to scare anybody away, but there's some stuff in here that you read it twice. I read a couple of paragraphs twice to really understand what you were talking about. But when you put the analogy in there, it's like, ooh, I get it. And now I've got a picture to frame the ideas on. So I like the way you did that. But push versus pull, I think that makes a lot of sense. Now, maybe hopefully you're gonna put a patent on that, so you can live kind of
based on that feedback, I think we need to rewrite some of the words if it was difficult to understand. That's what I'm getting from this.
No, not difficult to understand. Hey, I don't have the brains that you guys have, right? You guys have the big brains, and sometimes when you're reading a book written by somebody with big brains, it's you read it twice. But
so if I just summarize the push and pull thing at a very high level, because I think it might be useful. So if we think about pushing in a data virtualization, what we mean by that is broadly we're pushing processing into underlying platforms, underlying data stores and data engines, and then pulling is the reverse, right? So we're lifting that data and processing it in the data virtualization. And then there's the kind of the hybrid approach, which is doing a little of both, right, where it kind of makes sense. And this gets a little bit back to some of the, I guess, the optimization and the cost and the time pieces that Daniel just mentioned, where in some cases it makes a lot more sense to push processing down and have it processed, have the processing happen where the data is. In some cases, it makes sense to do the reverse, and in some cases, it makes sense to do a bit of both. And that's quite a difficult problem to solve. But with newer technologies, and I'll mention something like one of them, like faster networks, right? So if we consider the performance of networks, if I go back to when I started, in the industry, it was always we send the data over a network or even on disks or CDs or whatever, because the network bandwidth wasn't up to it, and then we get all the data into a place, and then we process it. But with the networks have come on leaps and bounds, and if you look at the infrastructure that lives behind the cloud platforms, they're not putting data on disks, and those disks being attached to CPUs. That data lives quite some far away from the CPUs, right? Even if it's in the same data center, and so there's tremendous networking between those. And so if we're able to move data across platforms between an underlying data platform and a data virtualization platform, and we're able to do that very fast, then that gives us options in where the processing occurs that perhaps we wouldn't have had maybe even 5, maybe 10 years
ago. Let me play back what I took away from that chapter and correct me on the parts that I missed, or maybe you can applaud that I even Adrian understood.
Well, if you read it, then that'll be a step up from the normal data book club things that we do together.
Indeed, yeah. So let's love the push that, right? And what I like about the way the chapter is written as well is that I don't think you guys, the intention wasn't to say one's better than the other. In fact, I would say the opposite. I think you did your best to keep them fairly neutral, to say, look, here's 2 ways to do it, and here's a hybrid. And if I'm talking about push, really what I'm talking about is trying to figure out, I think you talked about 3 alternatives. Either I'm pushing data from source A to source 2 and letting source 2 do it, or I'm pushing data from source 2 to source 1 and letting source 1 do it, or I'm trying to do part of it myself. And so there's primarily push first, one source to another. And the challenges there obviously is that sometimes those sources don't want to do the work, or they're unable to do the work, or moving that data across different sources creates challenges. I've seen that in real life, and I understand those challenges. That resonated with me. And then when you're talking about the pool, you're saying, well, hold on a second. Sometimes it makes much more sense to enable a central, you call it, your book, you refer to it as a DV engine, to allow the data virtualization engine to do all the compute, where it's pulling and it's doing the compute. And that you read that and you're like, yeah, that's brilliant. Let's do that all the time. But then you're fair in your assessment. You're like, hold on a second. But sometimes it makes more sense for the source to do it. If you've got an MPP backend source system that was designed to do that work, why wouldn't you leverage it, right? And so I like the way that you guys present the hybrid, to say is in a hybrid, maybe that hybrid section should be retitled ideal, but in an ideal situation, you're like, hold on, I want the best of both worlds. Maybe I want to do most of the compute where it makes most sense, but if I've got a backend system that's powerful, that already has the data, that can do all the processing on its own to limit how much I have to send back to the central node, so to speak, and I balance that with a worker environment where I've got multiple systems that can scale up or down to do the work that it needs to centrally, bam, right? Now you step back and say, I've solved the problem of moving data. I solved the scalability issue. And I'm able to communicate effectively with the systems, not asking them to do any more than they were designed to do. now you sit back and say, hold on a second, I've got something that works here. Give me chapter 3, right? Because I'm ready for the next one. But let me pause. Did I understand it, Daniel and Andy? Did I understand it correctly?
Yeah, it's very nice, Adrian. I think you really got the main gist of the second of each chapter. I just fix one thing. Basically, everything was great. I mean, but just one quick fix is just that when it comes to the push model, what we're really pushing is code rather than data. The pulling is we're pulling data, but the push is we're pushing code down. In other words, we're sort of saying, you do this work. Here's the work I want you to do, and I want you to do it. And you push the code down, and then the underlying system does the work, and then sends a result. Usually the results are smaller than the actual raw data. So most of the time, the push model results in less data being sent over the network, which is why it used to be so popular. Whereas pull is pulling the raw data out, which is usually much bigger. But at the end of the day, because Andy said the networks have gone much faster, that the pull makes more and more sense. And the key thing that pull does, which we haven't mentioned yet, but I think just to tie this back to what I was talking about before, is that when you're pulling data, most of the work is being done by the same system, right? The DB engine or the system that's receiving the data over the network. So if it's doing most of the work, then the sort of less sort of like complexity. It has to consider about what it's doing. It doesn't have to worry so much about what's being sort of done by other systems, which is much more complicated. So it is, as you said, Adrian. It's not always, there's no one right answer. Sometimes push is best, sometimes pull is best, and hybrid is towards the ideal way. So decide on the fly which is best for a particular situation. I think that is sort of the direction the industry is going. But there are complexities there as well. It's still not so straightforward. Sorry, go ahead. Sorry.
I was just going to expand when you said on the fly, and I think that's a really important point, right? Because it's at a query level. The determination should be at a query level for optimum results, right? So some queries are going to work best in one mechanism, and some queries in different mechanisms, and I think that adds to the complexity, but that also adds to the benefit.
Yeah. There was a couple of other pieces there that were introduced that I suspect are going to come up further in the book that I think are super important that maybe we're just scratching the surface on now, and we won't get into detail here, but we'll save it for the next one. But catalogs, right? You introduce, when you're talking about the push, you show some screenshots, catalogs, right? And super important, right? And then you start thinking catalog, you start thinking metadata, you start thinking, how do I optimize? To your point, Andy, if I want to optimize my query, I better have some good catalogs and I better have some good metadata, or else I'm guessing on the optimization. How important is that? I mean, can I optimize without good metadata?
I don't think you can optimize without the metadata. I guess we need to think about what catalogs are, because when we use the term, unfortunately, this is just a symptom of our industry, right? We overuse terms. And so when we think about a catalog in this case, we're thinking about what I would call a technical metadata catalog.
Backend catalog, yeah.
If you like, a backend catalog. A catalog that ordinary users wouldn't necessarily it wouldn't be something with business context and or an enterprise catalog, but a catalog that makes sense to the virtualization engine, so that it can make use of metadata, for connections out to underlying platforms, perhaps for statistical data about the data in the different platforms. Clearly, if you want to make the best decision on how to execute a query, then you need to know about the data. You need to know where it resides. You need to know kind of the distribution of the data, if you will. Because although there are, as we've talked about, faster networks, if you don't have to move the data over a network, and if it makes more sense to push processing down, then let's do that. And the catalog helps to the optimizer, if you will, to make some of those decisions. I think it's pretty important. And then above that, and I'll stop and let Daniel add some in a moment, but above that, obviously it's useful to have a catalog that an end user can actually see, because it's all very well connecting up a load of systems, but at some point we need to know, actually, is any of this data, where is this data and how relevant it is to my question that I've got that I want to answer. And that gets into a whole other aspect, which we probably won't have time to talk about today, but hopefully on another one of these, where we get into kind of some of the things that data virtualization as a capability enables.
I want to underscore that, though, because it's super important, right? we're talking about largely technology capabilities initially, right? We're talking about, wow, there's new technology that allows us to balance how we communicate with the backend systems, that allows us to balance who's actually doing the compute, that allows us to look at the work coming in, and the system can make a decision on how to distribute that workload and how to expand the workload. And that's all fantastic. But the part you said there is probably even more important, is that the end user, the human, if you will, the person that's asking the question, giving them the ability, either in a customer-facing catalog with data products, or a back-end technical catalog with data assets and schemas and tables, just being able to see what's available, and being able to kind of discover what's available before they start to even think about a query. That's powerful, because if you don't know what's there, you're not even sure what you're querying. But when you can see that in a catalog, I think that's just as important. And I think, to your point about what's changed today and why virtualization maybe works better, maybe that catalog is one of the reasons why it works better, is because now we're better empowering end users to see what's available so they can ask better questions.
Yeah, I think that's all true. I would also add that, as you said before, I think you have very good instinct, Adrian. There's going to be more of the catalog coming up in the book, and that's absolutely right. So we get into a lot.
I'm just teasing it. I'm just teasing it.
I mean, we didn't tell you this, but you figured it out, because it is coming. And the place where it's really coming is when we talk about the architectural principles of the end user. In other words, things like data mesh, data fabric, where especially data fabric, the catalog is so important there, not just for humans, but also for some of the automation that happens sort of to prepare data for the end user. So we definitely will be coming back to it in later chapters of the book, for sure.
Awesome. Fantastic. How has it been writing a book with Andy? I mean, I can't imagine. See, if we think about the push versus pull analogy, I can imagine working with Andy. Andy likes to push work towards other people, right? And so how has that been, you two working together? Has it been good?
Well, I thought they only added him, to the project because they were afraid that I would be too academic.
I heard I got added last week just to get his name on the title. That's what I heard. I don't.
Daniel likes a decent cup of tea, and so that's what I add to the project. I'm able to make a decent cup of tea.
I'm surprised, Daniel. He didn't make you put his picture on the cover. That was my surprise. I was like, what? No Andy on the cover.
I love working with Andy. I'll tell you that he really, Andy really, I think he's a very good compliment to me. That I do tend to get a little more academic in my thinking, and Andy does bring me to reality. So us working together on this really kind of brings the book to sort of both directions. Gets the theory down there with what are the fundamentals, but then also how do you actually use this in practice? I really, this pairing, I didn't know it would be so good going into it, but really, I'm really finding working with Andy to be really a big treat for me. It's very nice for me.
The check is in the post, Daniel.
but it's a good point, though, right? I mean, here, I think that's a really good point. You've got a nice balance of the brilliant academic, innovative view balanced with what Andy is seeing every day with real customers and real challenges. And so this isn't a book written in an ivory tower. This is a book that's basically written on the streets, so to speak, right? Fantastic.
I haven't really had that before. In my other part, usually I work in, write papers in the research world. Sort of I'm working with my students who are also sort of in ivory towers. So it's really, it's a new experience for me, but it's really, I'm finding it to be very beneficial.
You've already teased catalog as something, and data mesh and data fabric as some pieces that are coming in the later chapters. Anything else you'd like to kind of hint on, just to kind of get the audience excited?
Yeah, I'll tease the last chapter too. That one is the most fun one. I'm really looking most forward to writing, which is what's coming up next. What's the future of data virtualization? So where we said already that a lot has come very far already in the last, let's say, 5 years or so. There's a big changes in the data virtualization world, but there's more coming. I think that last chapter, the future looking chapter, that's the most fun one, because it's first of all, no one can disagree because no one hasn't happened yet, but just sort of thinking about what's the direction and what's going to happen in the next decade, 2 decades is I think it's going to be a fun chapter for both to write and to read as well.
Awesome. We'll have to jam generative AI in as well, because that's what everyone talks about, those words in every presentation. So we'll probably have to have those words at least once in that chapter, I guess.
But But I'm excited about that. I mean, let's let's tease that a little bit, right? I mean, the idea of using an ML engine, forget the generative AI, on the back end, an ML engine on the back end that would that basically sit and learn about the way the different systems are working and the way the queries are being drafted and the way the people are asking. So if these people are asking these questions, the system is distributing these queries in this way, and the systems are responding in that way. And maybe considering network utilization, considering location, everything else, and having an engine recommend an even higher level of optimization. Is that in the future, Daniel? Do you see that as a way forward down the road?
Yeah, I mean, it's already happening now already. Actually, we're seeing already, with both in academia and in industry, with much more ML going into the query optimizer, which I think is what you're talking about. With what you're, which really is making a big difference already, and is, the expectation will be even more of a difference, where especially in the data virtualization one, and one of the big problems we said before is you have different systems. So and different people running those systems. So we don't, there is no sort of intimate knowledge about how this other system works. When you have ML, you can develop that knowledge over time. Sort of, you sort of, as you interact with this external system, which you don't know so well, and you see this takes this time, and this takes that time, and if I try this is what happens. If I try that, that's what happens. Over time, you learn how to interact with the system in a more optimal way, and then you start seeing much better performance even in push-based systems.
If I was to take the ML subject and bring it up one level, so not in the optimizer, and I'm not sure where this is going to go in the book yet in terms of chapters, but I think there's an interesting discussion about historically there's been a lot of data engineering to build features that then inform the rest of that data science lifecycle process. So then we build our models to predict churn or propensity to buy or whatever it is. But we have to have the data first, and historically a lot of time has been spent building that data to give us the platform to build the models. I think there's a real there's a real impetus, in my opinion, for using data virtualization for that part of that model building process, right? So where the data engineers, the data scientists can grab data. Sorry, my son's just come and destroyed my desk. Where the data scientists, data engineers can come and grab data really quickly using the data virtualization tools, build the features very, very fast, very rapidly, get into the data science piece of testing out algorithms and models, and then iterating back very fast, which is something that I think a lot of organizations will benefit from, being able to tune models, retrain models, build new models for new applications.
Yeah.
And so I just think that's a cool application that maybe hasn't been focused on enough. But that's kind of one level up as opposed to ML in the optimizer.
Let me add something to that. Like, I think you're onto something there. So when we sell virtualization to an engineering team or an architecture team, a lot of what we've been discussing in these first two chapters resonates, right? Here are the challenges. Here's why it didn't work in the past. You've been trying to do that. Here's why it didn't work. Because that's when I read the chapter, as part of, in the back of my head, I'm thinking, that's why that didn't work, right? And so that's what I really liked about those first two chapters. And I'm sure I'll continue to kind of get those moments as I read the other chapters. But from a consumer perspective, somebody who doesn't understand architecture, doesn't care about architecture, maybe somebody who's just a consumer that's been sold, I'm an executive that's been sold on virtualization, they have a different lens on it. And for them, virtualization just means that it's going to be easier for me to get the data, right? I don't care about the sources anymore. I don't care about where it is anymore. I don't care about the cloud of the country. I can just get the data easier. If I want to create ML features, maybe I'm a data scientist, I've got my ML features, and I don't really care about where the data came from to create those ML features. And so maybe that's another lens on virtualization, maybe for the book or for the second release, is just an executive version of virtualization to say, and here's what it means for you, right? It means that we've abstracted all this complexity so that you can run faster.
Yeah, I think that's true. I don't know, Daniel, if you've got anything you'd sort of add to that.
I mean, yeah, sounds, yeah. I mean, yeah, I think I agree with what you said, Adrian. Yeah, I mean, that's, I think, yeah, I mean, in general, there's just a lot of different ways we can incorporate machine learning into data virtualization to get better performance in a lot of different ways, and I think it's one of them.
Yeah, fantastic. Well, look, I like I said, I don't need to oversell it any more than I already have. I truly enjoyed it. I'm not just saying that because you're my friends. I thought you all did a good job. I thought that second chapter was money. That was, to me, that out of the two, that second one hit fast and hit hard. So it's a nice job with it. I can't wait to read the next one. It's going to come out before the holidays, and I'm looking forward to reading the rest of it. I think we're going to do this again as you guys release the upcoming early release chapters. I will tell anyone who's interested, I hope everybody is, you'll be able to find a link for the book. So you can actually click on that link and you can download the early release. And you'll also have access to the soon release, so the upcoming release, so to speak, it's going to come next, hopefully in the next few weeks. And so how many chapters do we have in the book? Or is that a surprise? Is it 15 chapters? Is it 10 chapters?
Not 15. I think we're shooting for 8 to 9 at the moment. It all depends on words. It's more about words than it is about chapters, and how we structure the words, I guess. But yeah, that's kind of where we're aiming for.
I mean, we could write 5 books. It's just it don't fit in one in one book, so you have to really sort of.
This is going to be much bigger than Andy's pamphlet that he wrote before, so he's excited.
Oh, it's gone. I was going to say, I normally have my pamphlet behind me, my data mesh for dummies pamphlet.
Awesome.
It's really a very deep subject. The data virtualization is just, there's a lot to it, a lot of interesting things about it, and it's just we could go on forever. But that's why it's fun to write. You see, although we are kind of limited with how much we can write, but it's still really it's a very fun topic to write about.
Well, great job so far. I think you guys, the early release selection was the right one. I think it's going to get people excited. Anyone that's out there reading is going to anxiously await the one that's coming. Thank you so much for your time, Andy, Dr. Daniel Abadi. Appreciate your time and look forward to doing this again for the next chapter. Thank you.
Thank you very much.